Welcome back. Thanks for joining me again. It's time for us to get started on our first section, demystifying the cloud. So in the beginning, before there was a cloud, I had a Commodore 64. I'm just kidding. We're not really going to go back that far, but it does bring up the point that I started with a personal computer, as many people did. And on that personal computer, you put games, you put applications like word processing software, or maybe you kept track of your budget on the computer, but you used applications, and those applications ran and all of the information was saved directly on that computer. Well, as things evolved, something called a client-server architecture was created. So let's think about why we would need a client-server architecture. When you walk into a grocery store or a retail operation, that store may have multiple cash registers. And those registers all connect back to a central server that has all of the information about what they have in inventory, what the cost of each item is, what the ID number for each item is. That information is stored centrally. Well, in order for multiple computers or registers to access that information, it gets stored centrally on a server. Now, why do we need to do that? Right? So if we have this server sitting out here and you're sitting on your computer and you start to update the data that's on this server, but other computers that also need to access that data have the information locally, you can see how that would be a problem, because as you update the information on the server, this computer that's sitting out here by itself has no idea of the changes that you've made to that data. So by creating a client server architecture, we're able to have multiple computers that all are able to use that application and update it. So that's the importance, or why we created or use client server architecture. Now, as we think about how client server architectures evolve, this server, we're going to erase it. This server has essentially been replaced with the cloud. So when we say applications are running in the cloud, think about applications like Office. So if you use Word, PowerPoint, those type of Excel, those type of applications, they are all now, in many cases, running off of Office 365. You have things like Gmail or Yahoo Mail. You might also use something like Dropbox to store your data, or maybe even Google Drive. And quite possibly, you might even be using Microsoft OneDrive. What all of these applications have in common is that they are stored in a remote location. You're accessing applications that are running on servers that are owned by a third party. So this is kind of an evolution of the client server architecture. Now, in many cases, many organizations are still running a lot of applications locally within their own environment. But as things are evolving, we're seeing more and more applications being migrated into this cloud type architecture. So when we think about these applications, what makes up the application? So first, we have compute. So you can think of compute as the brains of the operation. And compute has the CPU, and that makes up the brain of the computer. And then you have memory, and we have something called RAM, which is random access memory. That's basically the component that makes up things that are remembered by your computer before they're committed off to the disk or to storage. So these two components are kind of the primary components that make your computer work. So think about when you go to use an application, you're like, man, this is kind of slow or this is kind of fast. That is being processed by the CPU and the memory within that computer. Then the next component is storage. So storage is where the actual data itself is saved and where the application is saved. The storage could be a hard drive that's inside of your local computer. It could be an external hard drive that you've attached to your computer to add extra storage, or it could be a cloud-based application like Dropbox, Google Drive, or OneDrive. These are all large storage devices where you can actually save that data. So your storage is the location where your data is saved. I'm going to talk about database before we talk about network. So we're going to describe a database as an application that stores data in a structured way that can be easily searched and retrieved. And then we have networks. So networks is a little bit more of a discussion. Let's think about your home network first. In your home network, you have a device that allows your house to connect to the internet. That device is typically something like a cable modem, might be a router. And this gives connectivity off to the internet. Now, inside of your house, you have individual devices. They might be computers, they might be tablets, or it might even be your phone. But these devices want to be able to potentially talk to each other, and they may want to talk to the internet. So in order for devices to talk to each other, we typically use something called a switch. Now, many people don't have an actual full-blown switch in their house. They might have a router that also performs that switching functionality. And all that's really happening in a very simplified way is they're all connected to the switch device, and they're able to talk to each other because they're all connected. And then the switch is connected to the router, which allows that communication to flow through to the internet. Now, anytime you want to talk to something that's out on the internet, let's say there's a computer out there that is housing something like Facebook. So when you want to access Facebook, your computer communicates through the switch, through the router, off to the internet to something called a DNS server. Think of the DNS server as like your contact list on your phone or like a phone book. You say, I want to access Facebook. The DNS server looks up Facebook in its list of contacts and directs you to the appropriate address for Facebook across the internet. So that's really an oversimplification of how it works. But at a basic level, we all need a network to be able to communicate. So then what happens is you have all of these different computers or networks that are connected to the internet. So this might be your home network, this might be your office, and this might be Facebook. And inside of each of these, we have a separate network. And all of these networks are able to communicate with each other over the internet. So inside of every network, you have those basic components: your compute, your storage, your database, and your networking. So let's think a little bit about what's called server sprawl. So as applications started to really grow and client server applications really took off, a lot of organizations started to that every time there was a new application that needed to be deployed, a new server would be set up. So what that does actually is create something called server sprawl, because those servers are not all fully utilized to their capacity. They have a lot of unused CPU, a lot of unused storage, and they aren't really working very hard. But people kept setting up additional servers instead of trying to consolidate these all on individual servers. So this started to proliferate. Many organizations might have, tens to hundreds of servers that aren't really being utilized to their full potential. So what started to happen from that is that many organizations started to face a lot of different challenges. And one of those challenges in particular was server sprawl, because the data centers started running out of space. And setting up a data center is not something that's really cheap to do. So running out of space became a serious problem for a lot of data centers. They also had problems with being able to support the power requirements, because even if you're not utilizing these servers to their full potential, they still require a certain amount of power and cooling for them to run. So a lot of data centers started to really be challenged by not having enough physical resources to handle these applications that were being deployed. Additionally, think about the administrative workload of managing all of these servers that nobody was really even fully utilizing. So those were challenges for the people running the data centers. From a business perspective, you started to see a lot of challenges for things like we have to pay capital expenditures to purchase servers. You could easily spend, $10, $20, $100,000 or more buying equipment. So these are capital expenses that many organizations were having to pay for and depreciate. And on average, the life cycle for equipment is typically 3 to 5 years. So you can imagine the ongoing costs that many businesses were having to pay to maintain these applications. And then you started to have a distributed workforce, people working from home, people who travel, your road warriors, multiple offices, maybe some remote offices. So a distributed workforce creates a unique set of challenges in that you have to be able to allow people to access their applications. And you have to think about security concerns. How are they going to remotely connect into the data center? How are we going to secure their connection into the data center? And that becomes a real challenge as well. Then you have the time to provision. If you set up a new server all the time, every time you need an application, you have to test the application, you have to test the hardware, and then the procurement process, and then finally being able to provision. So this process could potentially take an extended period of time. So this is just demonstrating how we are starting to see the proliferation of remote workers, road warriors, people who work from home, maybe remote offices. And again, all these people need access to our data center, and our corporate offices also need access to our data center. So again, how are we going to do this in a way that's efficient and cost effective while still being secure? That's where the cloud comes into play. So in the next lesson, we're going to talk about what clouds are made of and how they're utilized. Thanks for watching. I'll see you in the next lesson.